Oh, it's frozen. Let it go. Okay, so we were just talking about, we're going to go over the questions too, BC review number 5, and see what people have that they want to ask about. We will. But then they're going to get back their AP exams from the mock AP experience. Those people that took the mock AP on Saturday will get back Saturdays. And then they will have Mondays, which will get emailed to them by me because it needs to stay secure. It cannot be posted anywhere public, and my class folder is public so that anyone can click on it, parents, students, with Heritage Warriors emails and without. So I'm going to email you guys the Monday version that you can print out and use as a practice exam like the spring break, or you can save it like as a PDF and work on it with scratch paper. But you guys know, keep it organized, keep it detailed as far as multiple choice, section A, section B, etc. And it will eventually be due before the actual AP attempted, there you go, and graded, and then scored, because you guys will have the full document so you can go down and use the scoring like I do in order to give yourself a 1, 2, 3, 4, 5, mid, low, high, etc. Why do I want you to take another practice AP? Because we've been reviewing, and this is where you were 2 weeks ago, right? So I want to see where you are now. I want you to see where you are now, and I want to have you guys have another opportunity to find other mistakes. Remember, there are up to 3 different optional practice exams for bonus, but the one that will be required for Saturday people is Monday, and for Monday people, you're getting back Monday right now, and yours will be the Saturday exam that will be emailed to you. Once again, you can print it off or you can use the PDF. Remember, if you are scoring your AP, not the one that you're getting back today because I scored it. If you're scoring it, please remember to use the document that I send you and not use like another curving this, that, or the other, because depending on the year, it could be different. Does that make sense? Okay. And we'll see that today because some of you guys need to see the 2017 international exam, and some of you guys need to see the 2013. I think that was an international one as well. That was the Monday one. Let's go ahead and pray quickly for today. Let's pray for our kids that are gone and traveling and at Disneyland and this, that, and the others. Our Disneyland people I know are, well, Katrina's not even, anyway. She didn't do Disneyland either, right, because of Stagecoach. But she's coming back from Kansas today and then doing Stagecoach. She's gone. Anyway. Hi. And then we have John Reeves, who is out. And we have Noah, who, he got to go, huh? No, to Disneyland. Oh, goodness. He got to go. He wasn't sure yesterday. And then we have Brendan, who's just gone. And then we have... Yuki's gone. She's at Magic. Kyle, where's Kyle? He's missing. I just don't know. Otherwise, I think we're good. Okay. All right, kiddos, let's pray quick. Anything else we can pray for this weekend? Yeah, Lucy. Oh, AP Ken. Oh, that too.
My grandma's funeral.
Oh. Okay. Didn't realize that. I saw something in staff devos, but I didn't realize. Yeah.
Just like the stress of APs.
Yeah.
Kind of.
Okay.
I'm still been like sick this past week. So.
Yeah, it's been like all in here, huh? Yeah. Okay. All the different performances. Okay. Let's pray quickly. Father, Lord, I praise you for this morning. Almost afternoon, Lord, I praise you for each and every one of these kids, and I praise you for those that are with us and those that aren't. Those that aren't, Lord, watch over them, keep them safe if it be your will. For those that have been working so hard this semester and finally get a break, just pray that they'll have a fun day, a safe day, that they'll enjoy time with their co-counsels, etc., and that it can just be a blessing. Pray for those who weren't able to go, that you'll watch over them as well, as they're either going through school or as they're not here. Pray for those that are doing college visits, etc., give them safety, Lord. Pray for Lucy's family and just continued just strength and comfort, Lord. Let them know that you are near and that they can lean on you, that they can look to you. Lord, continue to just give comfort and strength as they're getting ready for the funeral on Monday. And sometimes it's just tons of things to get done and family coming in, and just pray that you'll watch over all those involved in the ceremony and the different preparations, and just pray that it can be a great celebration of just life of her grandma, but also with the mourning and with just all the hard things as well. Lord, just pray that you will just put special measure of grace on her and her entire family. Lord, pray for Kyle as he's not feeling well, and others also that might still be struggling with just trying to bounce back from being sick, and pray that this weekend can provide him a chance to rest and a chance for his body just to kind of catch up. Lord, we also want to pray for just all the special things that are going on as far as the play. They still have 3 more performances. They got through 1 last night, but there's still so much more work to be done, and they're tired and might even be getting sick and trying to make it through school today. So Lord, just watch over each and every one involved in the performances and the behind the scenes and everything in between. And that the play, we just ask if it be your will, by your mercy, that just the rest of the performances can get better and better, and that they can go well, and that the kids can just be really excited and proud by the time they finish on Saturday night. Praise you for who you are. Praise you for all that you've given. Help us to get some good work done now, and praise you just for Friday. We need the weekend, so pray that we can use it well and all kind of recuperate and get some rest before APs come, as Alan was asking. That's just a stressful time of year. Praise you that you are good. Praise you that you are in control. So help us now as we try to be productive with some of our time. In Jesus' name, amen. Okay, so BC Review number 5. I think we have all the attendances all marked down. Let's go ahead and bust out the questions that you guys have, starting with multiple choice. Let me flip the lights. I don't know why. I like it this way better. What do we got? Sure. I mean, answers are already up, right?
4, 7, 10.
Okay. You guys okay if we start there? Okay. Number 4, they give us summation notation for a Taylor series. And they also say that f is the function given by the sum of the first 3 terms, 3 terms only. So I went ahead and found those first 3 terms. And here they're right over here. I found the first 3 terms and plugged them in for f of x, but that needed to go inside my ln of. They were asking for the maximum value of that. Here's the ironic thing. This is a graphing calculator problem, as is shown by the decimals. Kiddos, we're not having to do this by hand. We're not having to do any sort of nth degree Taylor approximation of this, that, or the other. We're just being asked to find the maximum of this quantity. Now it's tricky because we would be thinking like alternating series error bound, we'd be thinking of the Lagrange error bound, we'd be thinking of all sorts of things like that. But they want the literal maximum value. They don't want an error bound that's outside probably of this, like a worst case scenario that's actually what it is. It wants the actual maximum. So the actual maximum, cool, let's graph it and let's find the max on the interval. Like, you have to be kidding. No, I'm actually kind of serious. Can anybody relate this to, if you guys figured it out, because some of you were doing on the BC FRQs for your video explanations, etc. Can any of you guys match this to a concept that most of our class got wrong on their FRQs? No. Maximizing. Oh no, it wasn't maximizing. It was close though. Speed increasing for parametric equations. Speed increasing. Most of you guys were like, oh, CalcAB, velocity and acceleration have to have the same sign. Here's the struggle. It's parametric. You have an entire function from the absolute value definition of velocity. So it literally was saying take the square root function for speed and just take the derivative. Is it positive or is it negative at the point? It being the derivative. Struggle. Yeah, we need to talk about it. So sometimes they're using things like remainders of Taylor series, or they're using things like speed of parametric equations, and they're asking us CalcAB stuff with it. But we have to kind of learn how to distinguish, because our brain has little presets that we can just kind of jump to. So this one, I think my brain, guys, it looks like I got it the first time. I didn't. It took me a while to figure this out. I had to play with it, and I was thinking Lagrange too, because maximum value. I'm like, oh, maximum error bound. Maximum bound is different than maximum value. They wanted the actual max. Fine, graph it, maximum, done. Make your window, though, the interval, or else it could just be a mess. Make your window the interval of 0.3 to 1.7. Corey, I got lost. What was your next one for? 7. Ooh, interval of convergence, testing endpoints. I like these ones. Could you guys kind of be reminded by testing the endpoints if you just checked out all the multiple choice answers first? Some have or equal to's. Oh, or equal to's. Maybe we need to check at the endpoints. Anyway, so testing the endpoints, that doesn't actually happen until we find the interval of convergence, right? So interval of convergence, I need the n plus first term. There it is. All over the nth term, multiplied by the reciprocal. There it is. Less than 1. Then, remember, we can technically take the limit of the n's and then the x's just kind of chill. So we ended up getting an x plus 2 left over. The n's, the degrees, end up being tied. Now pause. Can I give you a note on some FRQs I graded recently? Can you do this? No. That's not legal. I know what you're trying to do. You're trying to say the degrees are tied, the limit is 1. Then just do that. Please don't go canceling things out when they don't cancel out, because then I have to take points off, and I have to do the whole little like, yay, boo. Ah! Anyway. But you guys, wait. You see how that's illegal math, right? We can't just go canceling it out. They are not the same thing, okay? But what can we do? The limit is 1. Yay, okay. 1 times x plus 2. We can do that. We just can't go canceling out the little n's because it's not true, okay? It's false. Anyway, so now that I have taken the limit is 1. I have x plus 2 less than 1. I am in between 1 and negative 1. When we solve, we got it. How do you test the endpoints? Take the x, good, plug in, and then test the convergence of the remaining series. So if you plug in negative 3, that would be negative 1 to the n. Hey, that's an alternating where the limit as n goes to infinity is 0. Sweet. So that one is a yes, right, or equal to. But if I plug in negative 1, that'd be 1 to the n. P series, p equals 1/2. If Katrina was here, we would remind her. We're reminding you. P equals 1/2 diverges, right? So not 1, not negative 1. Number next one. We can go back to, sorry, I was doing Corey's. I thought you had one more. 10. There he goes. And then you guys be ready with another one because we can go back. Number 10. Oh, well, we'll use someone else's. Number 10. Equation of a, oh, guys. What was weird about this one? They gave you the derivative is 1. Okay, fine. Then take the derivative, 4x cubed plus 4x, set it equal to what they said it was, which is 1. That's going to happen at, oh, but how do I solve that? It's a cubic. It's a calculator problem. Sweet. How do I solve it? Guys, hold on. Pause. Everyone. Do you know how to use your calculator? Intersection between what and what? y1 and y2. Good. So I can do y1 and y2. Find the intersection. What's the other alternate way of solving, which is helpful on word problems where intersections might happen at 500 or negative 57, or I don't want to play with the window. How can I make it so I know exactly where to look every single time? Subtract the 1 and find the, this will always happen on the x-axis. So I don't need to go changing my window looking for the intersection. Now, this intersection would be in your Zoom standard. It should be fine. But just saying, you could subtract the 1, find a 0, and always look at the axis and not have to go looking up or down. Anyway, that's the x value of the intersection point, or the 0 of the expression when you subtract. That's going to be my a. Plug that into my f to get my f of a. I already know my derivative. Dun, 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 dun. Okay, another question. Caroline. How did I get that? 9, going back. I have no idea. That was so weird. I don't even know where that came from. I started to say something else. I don't even know what. Number 9. Not important. The base of a solid in a region. What am I popping up in? Semicircles. Remember, semicircles, you put this on the ground, right? You threw it on the ground. Throw it on the ground. You have your triangle, and you're popping up perpendicular to the x-axis, which is why I have dx, popping up in semicircles, right? Popping up in semicircles. Popping up. Guys, if those are semicircles, then what is my top minus bottom going to be? My diameter. So if my top minus bottom is my, now if they said quarter circles, right? If this was quarter circles, then I'd be like going straight up and then coming down, and this would be the radius. But since it said semicircles, now it's getting disgusting. I'm going with a half circle. This distance is all the way across. That's the diameter. So how do I plug it into my formula? Top minus bottom cut in half. To get my radius, when I square it, I get a 1/4 and a 1/2 makes a 1. Oh, I didn't even show it. Makes a 1/8. Sorry, there's a little squared over there. I had everything in terms of x because of dx. Dun, 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 dun. Does that make sense? You would have had to get this y equals. And then that would have been your top. Your bottom would have been 0, which is why I just have my little line, which got cut off. I cut it in half to make the diameter a radius. I squared it with a 1/2 pi for the 1/2 pi r squared semicircle area formula. Oh, because when we solve, you get 2y is equal to negative x plus 8. So then y is equal to negative 1/2 x plus 4. Does that make sense? Getting it in terms of x. Another question. Mm-hmm. The area formula for a semicircle is totally 1/2 pi r squared. But when you look at your shape, if you're popping up in a semicircle, this top minus bottom is not the radius. It's the diameter. So since my top minus bottom is diameter, my formula needs radius. I need to do my diameter cut in half. And when I square it, then you could think of it as there's a 1/4, a 1/2 is a 1/8. So I could have done 1/8, and I could have taken that away. That's what they sometimes do if they want you to like write the integral expression but not simplify. It's like a matching problem. Gabby? Okay. Hey, related rates. Guys, just quick heads up. In the AB folder, AB class folder, underneath their AP exam prep, underneath their laying the foundation reviews, I just handed out to them review number 12. Actually, we're going over questions today. It's a related rates packet. And it's a really good packet. Like it's how to do calculus speak, like how to translate things like the radius of a circle is decreasing at a constant rate of. There were problems where we just practiced. You might want to check out the video from this morning. It might be helpful because I feel like they had a much better grasp of related rates after we went over it today. And I have a whole packet if you want it to practice related rates too. Some people I know it's a weakness. But when you see the radius of decreasing at a constant rate of, radius decreasing rate of, I have time, oh, dr dt, decreasing, negative 0.1, got it. Then it says in terms of the circumference C, well, that's weird. Okay, I'll come back to that. What is the rate of change of the area? Well, dA dt. They give me dr dt. They want dA dt. They want dA dt in terms of circumference. Let's think about circumference off to the side. Maybe a good thing to put in your forever card if you keep forgetting circumference. Maybe in the pre-cal stuff. C equals 2 pi r. So then I went ahead and said, okay, I know A is equal to pi r squared. I can do dA dt is equal to 2 pi r dr dt. But I got rid of r because they said they wanted it in terms of C. So I went ahead and used my circumference formula to say, well, if you don't want r, fine. I'll go over to circumference, solve for r, and plug in. So I went ahead and got rid of r. The dr dt is just going to plug in the constant. So I was like, well, if they don't want the r, if they want the c instead, I'll use this little formula, rearrange, and plug in. Does that kind of make sense? Okay. Another question.
FRQD.
Okay. LNA multiple choice?
Yeah.
Which one?
2.
Okay. Corey, is there only one FRQ? Oh, yeah, we skipped one, right? Okay. For what positive values of A is f continuous for all real numbers? Definition of continuous, I can't have any holes or vertical asymptotes or jumps as defined by like a piecewise function, right? So looking at this, I mean, if a was a negative number, then x squared plus something would be impossible to factor. They'd be imaginary numbers. That's the only time I can think of where this could be continuous. A would have to be a negative number. So positive numbers, think about it. Whatever a is, couldn't you, any positive number, couldn't you do x plus the square root of a and x minus the square root of a? The only way that this would not exist, meaning these zeros would not exist, x equals plus or minus root a, the only way a square root doesn't exist is if a is negative. So it's kind of a weird pre-calculus problem, and I apologize. I haven't seen anything that pre-calculus in a long time on a calculus one, but yeah. Okay, any other multiple choice? Go ahead.
5, 6 feet.
Okay. You got like the different ones from Corey. Number 5, guys, you teach. What's someone need to remember for number 5? If you were doing a video on number 5, what would you say? Oh, not parametric. Okay, that's true. It's not parametric, but what else? Or just implicit differentiation, technically, right? Just don't forget the dy dx. So you just have to go ahead and chain rule it. Bring down the 1/2, negative 1/2 times u prime. U prime is 2 dy dx. Implicit differentiation. Pause real quick. I've been trying to stress to you guys, sticking it to the man, right? What if this was an FRQ? It has been, like a part A or something. What if this was an FRQ? Could you stop here? Here, with the dy dx? No, because they always want it in terms of your variables. So you would have to at least get this guy and plug it in. But couldn't you stop as soon as you plug it in with the square root of 1 minus y squared? Yeah. Just wanted to make sure you guys knew that. You said 5, 6? Guys, teach. Yeah, I would take the clue. I would plug in. I would simplify as much as possible, like 1g of x plus 1g of x is 2g of x. Then you can go ahead and separate. And as I separate, I check it. I integrated the 7 to be 7x. I can actually do that. And then I have this extra piece. Teach. There's a table. Gabby. Teach. Trapezoid approximation. Some of you did miss Riemann sums on the AP. It was not fun. Eason, give me your phone. Thank you. I'm just going to put it right here, okay? Number 8. 1/2 the 3 bases add the 2. What?
Yeah.
No.
Why not?
First, you have to check that the bases are equal. Are the bases equal?
Yeah, the 3 different bases.
Oh, like you weren't just having the 3. You were saying the 3 bases separate with extra missing stuff in between? Awkward. Okay. So yes, 1/2. Take a base. And what do you do to that one base? Multiply it by the 2 heights on either side. So the difference between 2 and 5 is 3, and then 10 plus 30, right? Yep. Okay. The next base would be 2, and then you... It's 2 heights. Remember, height 1 plus height 2. Don't we have forever cards that say the area of a trapezoid is 1/2 base times height 1 plus height 2? Remember, the bases come from subtracting. The heights come from the y's. If it's a left Riemann sum, steal the guy on the left, base times height. If it's a right Riemann sum, base times height. If it's a midpoint, why would this table never be a midpoint? You don't have enough to jump, right? Midpoint, you have to jump 1 because then you do a base times a height in the middle. And it might not be the exact middle, but a height in between. And then trapezoid, base 1/2 base times height 1 plus height 2. Is that cool? Okay. FRQ. Letter D.
Yeah.
It's the second one or the first one? First one? Okay. Situation. What do we got? Ooh, I like this one. What year is it? Okay.
2009.
Yeah, I didn't remember this one very well. It's been a while. A storm washed away sand from a beach, causing the edge of the water to get closer to a nearby road. The rate at which the distance between the road... Oh, papers! Guys, actually take them this time. I always get extra ones.
I'll take one.
Take one. Support our staff. I didn't mean right this second. Okay. Go team. Get one and get sit down. Because this was your question. All right, what do we got? We got a rate, right? A rate at which the distance is changing. The edge of the water was 35. That's our initial, right? Did anybody like make an actual expression for the distance from the road, like d of t or something? Did anybody make a letter for it?
A letter? What do you mean letter?
Because this is the rate, right? And then this would be the first derivative of the rate, which would be the second derivative of the distance between the road and the edge. No, I know. I was trying to. Let's do E. Edge. No, E is a number. Let's do F. Nope, F's already being used. G, D. Anyway, we'll do D of 0 is 35. The distance is 35 to begin with, right? Okay. The storm lasted 5 hours. So you guys are all the way down to D. After the storm, a machine pumped sand back onto the beach so that the distance between the road and the edge of the water was growing at a rate of. Okay, so they were trying to pour the sand in order to make the beach go backwards away from the road. Write an equation involving an integral expression whose solution would give the number of days, t, that sand must be pumped to restore the original distance between the road and the edge of the water. What was the original distance? 35. What were you guys able to figure out as you were going up through here as far as the integral expression for how much distance got lost? Because we have to figure out how much distance got lost. Okay, that's the general expression. So what did you guys get for part A? 35 plus 0 to 5 of f of t dt. Good. So integrating the f of t, integrating how much distance was being lost between 0 and 5. The storm only lasted 5 hours? Okay. So then the distance was getting smaller, right? Because f is a negative quantity. So then what's g needing to do? We have a new variable. We're not using t anymore. Now we're using p. G minus f, is that what you're thinking? F is negative in its nature, right? Because it's subtracted from? G minus f, wouldn't that add f? Because f is a negative in nature, right? Don't I need them to cancel each other out to get back to 35? So my guess would be g of, without thinking too deeply or longly about it, my guess would be g plus. Yeah, g plus. So what you were saying, Corey, was you were thinking g of p minus f of equals 35. That doesn't work because the problem is this f would just be how much distance was lost. It wouldn't be its actual position. Is that how that would work? The way I would think about it would be both of them would need some sort of initial position. Both of them would need some sort of initial position. So ultimately the 35 doesn't even really have much of a bearing in it. Because instead, if this is talking about the distance and this is talking about the distance, this is how much was being subtracted, this is how much is being added. What we were thinking was it needs to be g plus needs to cancel out. And when it cancels out, it will get back to 35. Does that make sense? So you could be actually using this expression and you would have had the 35 in that one, but you would have also needed the 35 in this one to some degree, and they would have canceled out. But it would be a little bit easier to say, well, they need to cancel each other out. How do they cancel out? We'll set them equal to each other. But this guy's a negative and that guy's a positive. Okay, cool. We'll throw that negative sign in. Or for those of us that were thinking through, if I needed the g in the integral, just shortcut notation, plus the integral of f, because this is already negative in nature, equals 0, then it would be subtraction when we go ahead and solve. Is that okay? Why is the x up there? In the top bound? Because you're solving for, the unknown is how many days? The unknown is how many days. So we know it's going to start at 0 as far as 0 days since the storm finished, 0 days since the pumping began. We don't know when it's going to end. It just said solve for, so then x can be our, well, I don't know when it's going to end. That's the whole point. When will it cancel out the damage that was done? When will it cancel out the damage that was done? Okay, that's it? Oh, Alan. Letter C. At what time during the 5 hours of the storm was the distance between the road and the edge decreasing the most rapidly? Decreasing, this is derivative, right? And then most rapidly, second derivative. So I want to find the minimum of f. Does that make sense? Because decreasing, that would be my first derivative, my rate, which is f. And then most rapidly, I need to think about the min of that. Yeah. So then what do I look at? Whenever we need to minimize or maximize, we always look at the quantities derivative. So I need to look at f prime, set him equal to 0 or dne. You could do a quick little, this is what I would do anyway. I would do 1 minus sine of t, nope, common denominators, lo siento. 1 minus 2 square root of t, sine t, all over 2 root t. That way I can do a quick little 0, top, bottom. T equals 0, okay, fine, forget him. This guy equal to 0, I could go ahead and solve, or I think it's a calculator problem, it's question 2. So we could go ahead and graph that guy, and we could find the intercepts of 0 starting at 0 is when the storm begins, right? T hours after the storm began. Looking between 0 and 5, because that's, it says during the storm, right? During the 5 hours of the storm. So I'm only looking at a window of 0 to 5. And as we look at the window from 0 to 5, there we go. We get critical numbers of 0.66187 and 2.84038. We also have to look at our endpoints because it wants the minimum, absolute minimum. So testing our critical numbers and endpoints by plugging into the original function saying, hey, well, what was your rate? What was your rate? What was your rate? What was your rate? Who's the lowest? Remember, test critical numbers and endpoints. Does that make sense? So then up here for the derivative, you would have wanted to use your graphing calculator to graph and find the zeros between 0 and 5. Then plug and chug. Yeah. You would have lost your justification. You could have still, because considering f prime of t, that's critical numbers. Answer, you could have still picked that guy. You just would have lost the justification because you wouldn't have been able to say out of all the candidates, this one was the lowest. Yeah. Any other questions on FRQs? Okay, let's go ahead and Cameron's gone today too, huh? Wasn't even paying attention. Gabby. Oh, you have a question? Yeah. If you're not grading, don't use it either. I have to be fair. I took Easton, so Dylan, I just have to call you out too. Which one for B? D. What about it? Okay. Let's go back to what letter A was. Letter A was the distance between the road and the edge of the water, right? And then letter D says that G is the distance between the road and the edge of water. Oh, no, it was going at a rate of G meters per day. So the road, okay. So then storm comes, right? Here's the road. Storm comes. F is how fast the water is getting closer to the road. How fast, it's a rate. How fast the water is getting closer to the road. So it's this distance getting shorter. This distance started off being 35, and then as the water came and rose in the storm, then the distance was decreasing down to whatever you guys found, 20 whatever, by solving with the integral. Okay? G, they started dumping sand, so it started going back. The long story short, when will you return to your original 35? Wouldn't it be when how much, not the water, but how much distance was lost will equal how much distance is gained? So you're trying to say, okay, let me set the distance lost equal to the distance gained. Now, distance lost, if you guys noticed, F is talking about the distance. You didn't have to put a minus in here. You didn't have to say 35 minus. It was already in the nature of the function that this function was showing decreasing. We already had the negatives built into it. So we said to do 35 plus the integral from 0 to 5 of ft dt to figure out the current distance between at the end of the storm. We don't have to really take into account the 35 at all. We just have to say, hey, how much distance lost equals how much distance gained. So we need to set them equal to each other. We need to go backwards from both of the rates. This guy, time, 0 was the beginning of the storm until the end of the storm, 0 to 5. This guy, 0, P, is 0 days that pumping has started to the end of the pumping, to the end of when they've finally reached back to their end goal of 35 feet. So we need both of these to equal 35 feet. But in order to do that, I need this, which shows the decrease, the amount decrease. I need it to be the positive measurement. I need the signs to be the same. So this one's adding, this one's subtracting to set them equal to each other. I need that to go ahead and equal. Another way of thinking about it, and this is probably how I would have done it. Just like we did in part A, where we said 35 plus the water lost. Well, I need the distance gained plus the distance lost to equal 0. I need them to cancel out. And that would have been fine. I don't think you had to actually get one solved for rather than the other. But I need the distance gained plus the distance lost to cancel out. Yeah. The variables are a little bit nasty as far as the P and the T, but I think most of you would have put the 0, 2. Just what got confusing was why that should be a negative and whether or not you needed to put 35 in there at all. Okay, with that, BC review number 5. Since Cameron is not here and then some of your classmates are gone anyway, I have to collect theirs anyway on Monday. Let me go ahead and collect this on Monday, but if you do need to staple anything, etc., staple is at the front of the room. Let me go ahead and pass back to you guys right now your multiple choice. Hold on, I hid them so that AB wouldn't steal them. Here we go. Let me hand back your multiple choice. This is not the graded multiple choice. This is just your multiple choice packets, like your A and B. I'm going to have you guys paper clip this to your actual AP, which is the graded Scantron and the graded FRQ. This is your actual AP, but these are the questions. So hold on to these. Don't put these away. You're going to paper clip them to the others. Eileen, here's yours. Caroline, here's yours. This was the Monday makeup. No. There's no grades on these. These are just the questions because you need them to do your corrections, right? It's in alphabetical order, so Kyle, Emily, Lucy, Katrina, keep passing then. Corey's going to keep passing out your questions. And I'm going to start passing out your graded FRQs and multiple choice. And as I do, let me pull up your guys' answer key. Oh, bummer. Okay, this is the people that took it on Monday. This is your scoring guideline as far as what the weighting was, what the curve was. You should get a different curve. Your exam was different. So this was your guys's. And then 66 was the min for a 5. And then this was the one that was taken on Saturday. You can say, dang it, but your test was different. You have to take into account the BC people. This is how they scored it that year in a way that they thought was consistent. So it was literally 1 point difference. AB had like a 5-point spread that was different, I think.
Those are the ones that are on here.
Thank you. So here's the 2 different ones. Let me go ahead and let me see if I can actually, can I do this? Okay, you guys see this, right? This one is the Saturday one. This one is the Monday one, okay? Here we go. When you hear your name, come on. Tom, Eason, Kelly, Corey. This is in backwards alphabetical order, I think. Now I have no idea. Oh, because you were the separate one. Brendan's gone. Dylan, Amy, Alan. Katrina, Lucy, Emily, Kyle, Eileen, Caroline, both of them got 4s. They're just not here. Okay. Kiddos, check out where you fell. Check out where you fell. Now, what is our goal? To get a 5. Yeah, our goal is for everyone to get a 5. That's definitely true. But what is our more immediate goal right this second with this information that we have? What did you miss and why? Some of you missed tons of points on the FRQs, and I was surprised. Doesn't mean that your score, some of you, your score still kind of worked out where you probably should have worked out, but some of you missed tons of points on the FRQs. Some of you guys missed tons of points on the multiple choice. I was like, what's going on? So what do I need you to do with these exams? Look through. Look through the multiple choice. Look through the FRQs. Why are you missing points? Reading them closely enough? Are you missing some of the keywords? Are you not knowing what to do with the words that you see? Are you having it right and making it wrong? Are you one of my simplifying and losing points from it? Multiple choice, same dealio. So what's our job? There's no BC review this weekend. What's your job? Work your way through the multiple choice. Work your way through the FRQs. Now, kiddos, we do have people who have recorded versions of the FRQs. I haven't made a big deal about it with period 1 or you guys today. I'm not posting answer keys to the FRQs yet. So my job for you guys, my homework for you guys, look through your multiple choice. Look through your multiple choice this weekend with a colored pen. See if you can figure out what you did wrong. We're going to spend a couple days going over questions that you guys have. Yes, we'll be able to kind of work in groups. However, I would also love to be able to answer questions that you have as well, except how many questions are there? Well, 45 and then, anyway, there's a lot of questions. I can't necessarily answer everyone in class. Remember, you guys do have different versions of the exam. John Reeves also took it with Gabby and Eileen and with Caroline, so you guys could kind of collaborate together. And everybody else is going to get that copy emailed out to them as well so you guys can see it. So, what's our goal this weekend? Start working on corrections on your multiple choice. Pause. If you like your score, good, don't lose it. Pause. Corey, what did I just say? If you like your score, don't lose it. How could you lose it? Slack off for the next 2 weeks. If you didn't like this score, it's not set in stone, and we've been working and growing for 2 weeks since you took it. Yeah? What do I want? 5s. From who? Everybody. Why? Because you can. But we just need to work to get there. Are we all tracking? Yeah. All right. I'm going to stop.